Hello everybody, today we'll be revising the equations of motion. I'll be starting from the basics, so if you're learning the equations of motion or simply want a recap, you're welcome here. So let's first go over some key terms and definitions. T refers to time. A refers to acceleration. V will refer to final velocity. Keep in mind, final velocity, and U will refer to initial velocity. Also, S will refer to displacement. You can remember these via the acronym TAVS. Huh. Let us start deriving the first equation of motion. I won't be taking the equation of motion at the start, so you can follow along. Let's start with the definition of acceleration. Acceleration is change in velocity per unit time, or delta V over t. Using the definitions from earlier, we can also write this as final velocity minus initial velocity over time. Now, if we take time to the other side, at equal to v minus u. Now, if we want velocity on the LHS and the rest on the RHS, we get velocity equal to u plus at. And this is our first equation of motion. Hey, let's start deriving the second equation of motion now. For the second equation of motion, we need to take a look at average velocity. Average velocity is initial velocity plus final velocity over 2, because there are two terms. Now, let's take a look at the definition of displacement. Displacement is average velocity into time. Now, substituting, we get displacement equal to u plus v over 2 into t. Now, if we substitute velocity for the first equation of motion, which was u plus at, we get u plus at over 2 into t as displacement. This becomes 2u plus at over 2 into t as displacement. So, since this t is getting multiplied by the whole term, if we cut off 2u from the fraction, we get ut plus at over 2 into t equal to displacement. Now, ut plus at squared over 2 equal to displacement. This is the second equation of motion, usually written as displacement equal to ut plus 1 by half at squared. Let's finally take a look at the third equation of motion. Since this is a bit more complicated, let us take a look at what we have to derive first. V squared minus u squared equal to 2as. The important thing about this equation is that there is no coefficient of time. and the first two equations have the coefficient of time. So we simply have to cancel out the coefficient of time from the first two equations. Let us start by taking a look at the first equation, v equal to u plus at. Now this means at equal to v minus u, or t equal to v minus u over a. Let's write that down in the corner to remember it. Let's move on to the definition of average velocity. Is equal to initial velocity plus final velocity over 2, and now moving on to displacement equal to average velocity into time. Substituting time from here, we get displacement equal to u plus v over 2 into v minus u over a. Simply switching these two terms up as same, because addition is associative, we get v plus u. Now this looks oddly familiar, since this is the formula for a square minus b square. A square minus b square equal to a plus b and a minus b. So this becomes v square minus u square over 2a, and this is s. Now simply moving this up to the other side, we get 2as equal to v squared minus u squared, which in fact is our third equation of motion. Let's take a look at all three equations of motion in short. The first equation of motion is final velocity equal to initial velocity plus acceleration into time. Second equation of motion is displacement equal to initial velocity into time plus half of acceleration into the square of time. Third equation of motion is 2 into acceleration into displacement equal to final velocity squared minus initial velocity squared. Thank you.